chemistry mod and on the Immersive Minds live stream. We are broadcasting across YouTube. We're broadcasting across what else? My God, what are we? We're YouTube, Twitcher, Mix, Twitter, Facebook, and I think that's it. So, crazy times. Here we are. Here's my face. Hello. I like that offline graphic. What do you think, viewers? That's a better way to start rather than that. So what I can do is I can get myself set up with, let me just block, where is it? That. Nope. I get this right. I get this right. There. No. I can't see it. I think it's my MC Edit one. There we are. Block that and switch to that. Robbie Hayes is with us. Hopefully Thomas is back as well. Thomas Baldoff came in and then I had to stop the stream and come back again. So hopefully we haven't lost Thomas and he's back with us. Yeah, I kind of like the virtual effect as well. Baramok's with us. I like this though. This is like, welcome to my garden. This is where we hang out in the backyard. I kind of like that. It's my digital backyard. So many jokes. Lukash, I salute you. Welcome to the stream. Have you been on before? We are doing Minecraft Education Edition, and we are hopefully doing it well. So today we're going to be looking at the chemistry update, which is something I haven't covered yet, but it's something that we are doing a lot with. More increasingly so. I think when it first came out, we weren't entirely convinced about it. And my thoughts on this, and I just need to put this out there as an educator, you know, looking at this. When it first came out, there was this big emphasis on it. We must talk about it. We must run with it. We must do lessons with it. You know, from the Microsoft side, there was this idea that it was like the next big thing. And my issue with that was, if I stood in front of 200 educators, which is not rare for me, how many of those are scientists? And of those, how many are chemists? And of those, how many are chemists who play Minecraft? And of those, how many are chemists who play Minecraft who think that the chemistry update might help them with something that they're currently doing in their school? And so what we end up with is you go from 200 all the way down to maybe this one person in the room. And I don't want to spend a third of my entire training day talking to one person. I need to talk to 300 people. And so I think while the chemistry update is fantastic and we're going to go through it and show you just how fantastic it can be, I think it was one of those things that needed to be marketed differently. It needed to take time for people to invest in, including me. And only now have I got clients, and this is some 2 years later, have I got clients going, is there any chance we could start thinking about the chemistry update? And that's like 2 years in. And I think it's because we needed to sort of lay the advice and the kind of the theory of that chemistry updates over time. So let's have a look at it. I'm just going to start a little world here. And actually I'm going to go into new world and then templates. Here's the great thing about it. You'll see there that among the templates is the chemistry tutorial. This is how you can learn what to do with it. So we're going to go through the tutorial first of all, and then we're going to go into some of the worlds that we've been using in classrooms and see just where we can use the chemistry update. So we're going to click on this and go play. Well, I'm glad you're with us, Lukash. Welcome, welcome, welcome. I hope you and all of your loved ones are safe in Poland, and you're all looking after yourselves and each other. So, welcome to the exciting chemistry world. And then you'll notice that there's some plates down here, and no surprise, when we walk on these plates, World Builder ability has been revoked, and that means that we are not allowed. Oh, we are. Look at that. I thought we weren't going to be allowed to destroy the world, but we are. Okay, follow the path to learn the basics. So let's do that. Let's follow the path. So here's the tutorial. The element constructor creates elements by moving the sliders to choose the desired numbers of protons, electrons, and neutrons. A brilliant song, by the way, by the Cat Empire. Protons, neutrons, electrons. If you check out that song by the Cat Empire, it's just about life. It's about recognizing that you're just one human being in billions of others, and you just have to get on with it. For example, hydrogen equals 1 proton and 1 electron. Sodium equals 11 protons, 11 electrons, and 11 neutrons. So try below. So what we're going to do is go into this block here, and this block is called the element constructor. I can place a new one here if I just take it and pop it there. So it's got this little magnifying glass on it. Is that what you got? Microscope. Microscope, that's what it is. And then when we click on this, it said 1 and 1 gives us hydrogen. So we're getting 1 electron, 1 proton, gives us hydrogen. So let's look at how this works. Here's our protons. This is this column here with a plus and a minus. Here is our electrons, plus and minus. Working slightly differently in these rings, which is great. I'm assuming that's a scientific chemistry theory that I don't know about, but we're going to learn. And then here's our neutrons. What does neutrons look like? Oh, they just build up. Look at that. Ooh, I love that. I think that's fantastic. But we have to put them in at a specific ratio to each other, and we're doing ratios, right? That's what we're doing here. Or we don't get, or percentages even, but certainly ratios, or we don't get the right thing. So 1 proton, 1 electron equals hydrogen. So we're going to take that hydrogen. We can even take another one if we want, or another one. We can collect hydrogen. We're not allowed to stack. Oh, we are actually. I thought we weren't. We're allowed to stack those, so that's great. Whoops! I've just automatically given us 154. Now, what I like to do with that is play around. So what if we had 1, 1, and 1? We still get hydrogen. 2, 2, and 2. Oh, look, we get helium. So 2, 2, and 2 gives us helium. What about if we take away those? Yeah, we need 1 neutron. So 2, 2, 1 gives us helium. That's nice. What about 3, nothing, 3, nothing, 2, 3. Oh, 3, 3, 3 gives us lithium. Look at that. So now we can start to see from a molecular basis how these things are made up. Like, what are they? And what would be great is, of course, to have the table of elements up. So let's see if we can find that somewhere in this world. Personally, I know it's here. I just wouldn't necessarily have it where they've put it. But we can have a little look around. I'm going to have a quick look and see if I can find it. There it is. So it's down here. And I think it should have been in the main hall. But now we can see what the table of elements looks like. If we head to the other side, there we are. And we can find lithium. So where's lithium? It's blue. So I would think it's there. Look, there's lithium. What about helium? Where's helium? It's pink. And so we're going to have a look for slightly different colours from the bottom, am I right? Oh yeah, over here, look, there's helium. A light gas. And then if we look at hydrogen, it's green. So there we go, hydrogen. Quite opposite to helium. And we can obviously do all the learnings around and about that. Okay. Purple, not pink. Sorry, Baramok. You're a scientist there, sir. You're a scientist. You'll enjoy this. And so, I like playing around with this. What does 4 and 4 give us? Nothing. 6, 6, 6. Bum, bum, bum. Carbon. What about 50, 50, 50? Let's just try. I'm just mucking around now. I mean, I might be way off. Nothing. 50, 50, 50 gives me nothing. Or nothing that we know of. Nothing that we've yet discovered. Let's go down to the bottom and try again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's try. Oh, 10, 10, and 10 gives us neon. Yes. And to their neon gods they prayed. Name that song. 11, 11, 11 gives us sodium. So I love this, right? So I can muck around with this all day long. The problem is, as a non-chemist, I'm then thinking, okay, so I got myself some hydrogen, what next? I got myself some neon. Can I make neon lights? I don't know if you can. And so what we now need to do is we need to go on to the next one, which is the compound creator. So we've dealt with elements. Now what we need is to create compounds. So the compound creator, combine elements that you've made into compounds. Try creating sodium acetate. So that is, it gives us what sodium acetate looks like. And you can look at some of this stuff up on the internet. C2H3Na02. So what that suggests is that it's carbon 2, hydrogen 3, sodium and oxygen 2. Using the materials found in the chest. So handily, they've given us a chest where we can do that. So let me just clear my inventory. And we're going to go carbon 2. Now we know that was 666, right? Hydrogen 111. Sodium was 221 or 331. And oxygen we didn't get yet. So maybe we should look that up, actually. Let's go back and do that. Let's see if we can find... So let's see if we can make these. I'm going to match them up here. So we know, just because we played around to see what these numbers were, 666 gives us carbon. So we're going to match carbon. So we know that. Hydrogen was 111. Or 112, doesn't matter. Hydrogen 111. Sodium. That was helium. Lithium. Boron was 555. Keep that in mind. 666 was carbon. 777 was nitrogen. We're not asked for that. 888. Oxygen. So 888 is oxygen. Ooh. Has that got something to do with the ones there? Look, 6, 1, and 8. Genuinely, I don't know if that's true. Is that how chemical things are numbered? Because that makes total sense to me. So what I'm doing now at this point in my mid-40s adult brain is going, oh, wait a minute, that's what that number does. So sodium should be, now by that calculation, that should be 11, 11, 11. I've just learned something. Genuinely. I can just imagine myself in my chemistry class with Mrs. Gordon going, Miss, do these numbers... And she's like, yes, Stephen, that's what I've been teaching you for 4 years. Only it took 40 to sink in. Right. So that's what those atomic numbers... Yes, Barry. I'm amazed by that. So now I know how to then go back and get those from the Element Constructor. Oh, I'm so happy with myself. Right, so then we go into the compound creator and we put in 2, 3, and this, and we get sodium acetate. So by putting them into the compound creator in any order, we get this. So yeah, right? Look at that, Lukash. We've learned something today. I mean, not just about Minecraft, but about chemistry. I love that. So I've learned that those numbers in the top right-hand corner are the matching atomic numbers to be able to create them. I just love that. Okay, so that's going to give us our sodium acetate. Yeah, not all of them will be equal. I get that for sure. Okay. And then we go to, so that's basically worked. I wonder what else we can make. We'll maybe come back to this and see what else we can make. Although I think the tutorial takes us through some other things. There's a chest over here. Look at that. Oh, that's got some stuff in it. That hasn't. Right, okay. Let's head back here. So the lab table. Discover amazing products made possible through chemistry. So add elements and compounds to the table, then press combine when ready. Use the materials provided. Try creating an ice bomb using 4 sodium acetates. So if I go in here, and this is just going to give me more sodium acetate. It's almost like, if those of you in the UK that are watching might remember a program called Blue Peter. Here's some sodium acetate that we made earlier. And then what we can do is we can put it in here, and we need to combine 4 of them. So that must just be because we need a certain amount. So 1, 2, 3, 4. And then this thing up here is animating. And we're going to click... Now, if I take one away, it doesn't. When I click up there, it gives us a suggestion that this is now working. So I'm going to go combine, and we're going to get sodium acetate, an ice bomb. So what does Irene say? Hey Irene, we have even more resources available online, and you can go to the lab journal in here. Okay, bearing in mind everyone, this is free. So now I'm going to just head down to here. The reason I know how to go down here is because I've done this before. Then we're going to throw this ice bomb at the water, and through some code we can change the water to ice. I'm assuming that works in real life. I haven't tried it, but I'm assuming that this is part of a let's freeze the waterfall. Oh, it works. Yes. Oh, now I'm going to end up with a flood. Yes. What happens if we throw it at a tree? Is this what they used to kill? Is this what they used to kill the predator? Not the predator, the Terminator. Remember that Terminator that could walk through things in Terminator 2? This is what they used, wasn't it? Did they not freeze him and then destroy him? Sorry, Irene. Doesn't work on Irene either. Okay. Okay. Right, so let's try this. Done a wee research. The number of protons. So Robbie Hayes tells us that the number of protons in the nucleus of an atom determines an element's atomic number. So we're really just dealing with the first column. So let's just go back and talk through this because Robbie's doing the research for us. If we right click on this, it's the number of protons, i.e. 1 or 2 or 3 or 4 or 5 or 6, whatever. In other words, each element has a unique number that identifies how many protons are in the atom of that element. For example, all hydrogen atoms and only hydrogen atoms contain 1 proton and have an atomic number, therefore, of 1, which means we start with 1 proton and can experiment from there. So there's our hydrogen. If we go to 2, nothing, 3, 4, 5, 6, 7, nothing really. Oh, that's because it said only hydrogen. See, so then we don't have to go up because it says only hydrogen. Dr. Harves says liquid nitrogen. Is that what they killed him with? Liquid nitrogen. I wonder if we can make liquid nitrogen in this. I'm learning. I didn't do chemistry. Well, I did science at school, and chemistry was, of course, a part of that, but didn't actually do, focus on chemistry. So this is fantastic. So only hydrogen. Said that. So what we've then got, so he said, for example, all hydrogen atoms and only hydrogen atoms contain 1. But if we did 2, we're still not getting anything there. Maybe 2's not the magic number. What's 13, 13, 13? Nothing. 12, 12, 12? No. Magnesium. This is fab fun. I wonder why it skipped 13, because we get silicon at 14, but we get nothing at 13. Maybe because I've done too many neutrons, sorry. Nope, neutrons don't matter. I'd need to go and find out what these, I don't know what a proton, a neutron or an electron actually are. So that's another area of learning that I would have to do for myself. Only 1 proton, so hydrogen, yeah. There we go. This is such fun. Right, okay, so let's see what else we can do. Great to have you in as well, Doctor, on Twitter. Thanks for joining and helping me out. If you're a chemistry teacher, this is going to be good for me. Not for you. It's going to be good for me. It's going to be painful for you. So we made some ice. Let's see what else we can do. What's over here? This is just messy. The teleporter I don't want to use. Okay, so the material reducer. Now this is the one that we do use. I love starting with this in the lessons that we've used for volcanism. Looking at volcanoes. For example, we've been able to do this. So matter is made of elements. All matter, I imagine, is made of elements. The material reducer will reduce Minecraft blocks into their component elements determined by percentage. I love this one. Give it a try with the provided materials. Note that some Minecraft blocks, such as soul sand and netherrack, contain mysterious elements yet to be discovered in our world. Let's forget the fantasy part. Let's stick to the real world stuff for the moment. But if we right click on this, we're going to go into the chest and we're going to get ourselves some lava, which I love. Water. We'll find out what water's made of. Magnesium oxide. Grass block. Quartz. Oak. Stone. And we'll leave netherrack and so on out because they're the fantasy ones. Right. So lava. If we put it up here, it breaks it down. It tells us it's 47% oxygen, 28% silicon, 8 aluminium, 5 iron, calcium, sodium, potassium, and magnesium. And you see now, this is where one of the things I always thought, I assumed sulfur would be in there, but I don't know what I don't know if sulfur is a gas or if sulfur is a compound. I don't know. So I was always like, but didn't the people in like Pompeii, did they not die because the sulfur fell through the ash onto the fell with the ash, and it was the sulfur that killed them? I might be totally wrong, but I can see that sulfur's not in there. But that's good because then we can take the elements of this. And actually, I'm going to try something. If I take that, does that mean if I go back to here to my compound creator, and can I make? I don't think I can make lava, right? No, I can't make lava. That's a shame. Reverse engineering it would be nice, but I can't. But at least we can tell what it's made up of. What's stone made up of? There we go. 33% silicon, 64% oxygen. No, actually 67% oxygen, but you can only stack to 64. So 67% oxygen. Sulfur's a solid. Sulfur's is it? Sulfur's a solid. I thought you breathed sulfur. He says, coughing at the thought. What if we take away oak log? Look at that. Oak log, 49% carbon. So we could talk to the kids about that and say, well, actually, why do we think there's so much carbon in oak logs, but no carbon in stone? I mean, that would be a question for me. I'm the kind of kid that asks if worms have lungs. Like I'm fascinated by these tiny creatures. I'm like, do they have lungs? Do they breathe? And if they do, isn't oxygen like really big for them? Like oxygen gas, like oxygen is that not like really big for their little lungs? Because when I go, I can breathe it in and it's minuscule. But if I am like a mosquito, which is even smaller than a worm, if it has lungs, isn't air really big for it? Or am I just watching too many movies about people getting shrunk? But oak logs, so they have carbon, they have hydrogen, they have oxygen, and they have nitrogen. And nitrogen makes sense to me because that's that thing that you have to feed plants nitrogen when they're growing. Give them nitrogen so they can grow, right? Is that not what you do? And another thing is that because they're storing carbon and then they let out oxygen, or vice versa at night. So there's a constant flux between these two. These are just questions. I don't know the answer, but these are questions that I would have and I would want to talk to my children about, for sure. And then what else did we have? We had one more, didn't we? Quartz. 33. So it's the same. Quartz is the same as stone. 33 and then 67. Wonder what else you can put in. Let's play around with this a bit. Let's try two different types of wood. I know, but I'm just going to try it. Jungle planks. In fact, no, let's do actual logs. So let's see if a birch log is made up any differently than an oak log. So we know that that's 49, 6, 44. 49, 6, 44. No, it's the same. Okay. I thought it would be. chemistry teachers everywhere rolling their eyes at that. I'm just like, tell me he didn't just try to see if there's a difference between two different types of wood. Hardwood and softwood though, surely that's different. Like if you've got a softwood tree and a hardwood tree, would there be a difference between those chemically? Right, so they don't just give out carbon, they store carbon, but they give out carbon dioxide gas, which I assume is then part of the process of taking the carbon in and then releasing it later. But again, I don't know why, but this is what's lovely about this. And again, I've said at the beginning that I struggle with the chemistry mod as an all-rounder, everyone should do this. But if you are teaching chemistry, or you have an interest in chemistry, then this is fantastic. And I suppose what I'm looking at is, for this one, is the questions that it raises. I'm a questioner. I'm constantly questioning how and why things work the way they do. So for me, this is perfect. I'm just like, oh my God, that's amazing. So let's try something else. I'm going to clear my inventory, and then I'm going to go in and we're going to try some other stuff. So what should we try? So there's no difference between two types of wood. What if we did glass? Let's just get standard glass. And wool. Shall we try concrete? We'll try concrete. What else shall we try? Ice. Just to see if there's a difference. Mushroom. Let's try mushroom. I think I've missed most of it. Yeah, they're all up there, look. I think that's it, because they're all variations. Oh, sand. Let's see what's in sand. Where is sand? Why can't I see sand? You know what? I'll just search for it. Okay, let's see. Oh yeah, ores, Barry. Ores. Whoops, that's me bringing up the... Right, okay, let's try ores. So let's see if we can get lapis and diamond. Let's see what's in diamond and iron and coal. We'll get ourselves some coal as well. I'll miss out mushroom for the moment. Yeah, let's try that. So let's look at glass. Nothing. So you get that's odd. You can't do that. You can't do it with wool. Let's put these aside. You can't look at concrete, and oh, you can look at ice. Hydrogen. So 67 hydrogen, 33% oxygen. Was that the same as water? Let's try. Let's go and get ourselves some water. Was that the same? So let's look at water. Yeah, 67, 33. So ice and water are the same, naturally. I say naturally, like I knew that. I assumed that. Coal, right, okay, so coal gives us hydrogen, 50% carbon, 45% oxygen and nitrogen. And of course, why... any chemistry teachers watching, don't laugh at me, but if I take 6, 50, 43 there, and in this row here, so that was coal, but if I now go back and get myself some log, let's match this up. I'm just going to get rid of that back in there. I'm going to say that is carbon, hydrogen, oxygen, nitrogen. So the tree is just 1% out on these two, on the carbon, and that's maybe, I mean that might not be entirely accurate, but coal and the tree, because remember we 3 streams ago we did coal, and we looked at how coal forms underneath the ground in Minecraft. Well, it doesn't, but how we could make it form using code and create the 4 conditions for creating fossil fuel. And so now what we can do is, as a lesson, we can go into the chemistry piece and say, look, if kids don't believe it, you know, there's kids going, hang on a minute, coal's not made of trees that's 400 million years old. And you say, well, actually, look, it's practically exactly the same thing. That's given me an idea for one of my one of the lessons, is to have have one of these in the base to say, look, this is how it works. We should maybe do that in our toy box, where we have our coal piece, our toy box, is have a, what's the chemistry of our renewable energies and our fossil fuels? Because surely on a chemical level, they can be proved to be better as well. Even just, you know, like we burn less of this or we produce less of that. Because in this case, I mean, when we burn wood or we burn coal, we're releasing 50% carbon. Correct me if I'm wrong, if that's not the way it works, but I think that's the point, is that we don't want to burn these things because we're releasing the carbon, and we're releasing 50% carbon every time we do that with a tree or a chunk of coal or a whatever. Okay, so that's what that looks like. I've never done that before, so that was interesting. Let's try sand. Sand gives us silicon. So that's the same as stone. So again, let's put sand there. Which is interesting because it's not stone. Sand traditionally isn't stone, right? Sand is the creatures that's all crushed up, isn't it? So let's put the stone in, and that's going to give us silicon, oxygen. So that's the same. Well, I think it is, Barry. I think sand is, Barry's saying, is it stone broken down? And I think it is, but I also understood sand to be, I thought sand was like all of the creatures, like the shelled creatures and the mollusks and all of that. So when you pick it up and you run it through your hand, it's like, it's more that. But that's just how I understood it to be. I guess it's not. I guess it's stone that's ground down and down and down over, you know, thousands of years in the sea, I imagine. And maybe that's why, I mean, it's a shame that we can't get glass. Because if we could get glass, we could, because you melt sand to make glass, right? Is that not how that works? So surely if we could get glass, we would end up with the same row. Glass is a degree of silicon, oxygen, and, well, silicon and oxygen. The silicon makes sense for glass. Right, okay. Lapis. Ooh. So lapis lazuli is sodium, sulfur. There's sulfur. 16. Aluminium, oxygen, and silicon. So let's just have a look at this. If I just put this one here. So we're going to put silicon, oxygen, aluminium, sulfur. So I'm just matching it against these. Ignore these ones just now. I don't know what's going on there. I can probably put, that's not going to let, it's because it's nitrogen, right? I'll just get rid of that. Yeah. So if we match these against each other, even though they're found, like lapis is embedded in the stone, it's a totally different thing. But it does have matching. It has quite a high concentration of oxygen, much lower silicon, and so on. So this is nice. I like the material reducer because we can muck around like this. One of the questions that, let me just clear my inventory. And then let's go back in. One of the questions that Barry had was, I've done it again, are they the same? Coal, I've done it again. See, you know what I'm going to do? I'm going to go and switch it off because that is a pain, that button there. Code builder. Oh, I can't. Never mind. Let's see if coal... Anyway, after this, we're going to go and see. So we've got a block of coal. We've got coal ore, coal, and charcoal. Let's see what they look like in the material reducer. So charcoal first gives us carbon, hydrogen, oxygen. Oh, we're not allowed to put coal in. All right, that's weird. We are allowed to put that coal in, which gives us, so let's just put that at the end and that at the end so we can see what's what. So let's put hydrogen in, carbon, oxygen, nitrogen. So that's interesting. Coal as an ore has way more carbon than charcoal. And is that because, any scientists out there, my theory would be that that's because by the time you've got charcoal, you've burned all the carbon away. The carbon's been released. So what you're left with in this little charcoal pile is the carbon that didn't burn off. Yeah? And the oxygen. You've lost almost all the oxygen in charcoal because you've burned it already. And the nitrogen's gone. Is that because the nitrogen burns off as well? Does nitrogen burns, right? Is that why in like Mad Max, he has like a nitro burner on his car in Mad Max Road Warrior? Because nitrogen... This is the world. These are the connections I make. Okay, so the doctor says, yes, it reacted with the oxygen. The nitrogen reacted with the oxygen. And the nitro burner is that how you, like nitro can make a car go faster? And then what about coal? Oh, we're not allowed a block of coal. I know, right? Barry says, I love how all your knowledge is based on films. Mad Max is one of my favourite franchises ever. Like, Mad Max is the best. And the computer game by Warner Games is astounding. Like, it's genuinely immersive, dark, foreboding, post-apocalyptic, but still, like, hopeful. I love Mad Max. So we weren't allowed coal and we weren't allowed blocks of coal, but we could look at coal ore and charcoal separately. And I've really enjoyed that because that's given me, I'm thinking, right, so the carbon was burned off, which is why we've ended up with less of it. And that tells me that, you know, every time, because these big concepts are hard to grasp, right? When people say we shouldn't be burning coal anymore because the carbon goes into the atmosphere and gives us global warming. I hugely believe in all of that, and I think we should be doing way more for our planet in those regards. But it's still hard to grasp, right? It's still hard to sit in your little comfortable armchair and think, every time we burn coal, this stuff goes into the atmosphere that then messes with the weather. Like that's like big concept stuff. But even this helps for me anyway. Even this helps because it's like, all right, so charcoal is what is left when we burn wood or coal. And remember, we also know, let's go back and do this so we can just see what this looks like. And in fact, I'll reverse the theory. So this is how it's explained in my head anyway. Let me put that back down. I'm going to leave coal where it is, but I'm going to take charcoal to there. And I'm going to say, and then I'm going to put nitrogen, oxygen, hydrogen. So there we go. So wood and coal are practically the same thing. And so when we burn them, what we're left with in the bottom of the fire is charcoal. And we can see what's happened in the burning process. We've lost most of the carbon, and that's the stuff, where did it go? It went into the atmosphere. It turned into I'm assuming it turned into a gas and went into the atmosphere. Because there's only three forms, isn't there? It's like solid, ice, liquid, water, gas, mist. Is that right? What would you call water as a gas form? Mist. Steam is the gas. Not mist. States of matter, right? So there's only three, and so if a student says to me, "But where did the carbon go, sir?" Well, it turned into a gas in the heating process, and it went into the atmosphere. This is probably the worst science class ever for somebody. Anybody who watches this stream back on YouTube is going to be like, "What the?" You know what? It's just curiosity. It's just asking questions and learning from each other. Steam, right? Yes, steam. Yes. So the doctor tells me it's steam. That's fantastic. Right. So oxygen, and the oxygen has also reacted with the nitrogen, and the oxygen's depleted and the nitrogen's gone. Mad Max is miles up the road at this point. And so, yeah. I love that. I'm going to take a little screenshot of that, just to put out as a tweet to say, this is what we did today. Okay. Now, let's see. So we did coal, we did water. So let's move on and see what else there is. So these are just, this is all just kind of making it look as if the lab's doing its thing. Okay, so let's head down here and find out what else there is to do in this. Glow sticks. Use dyes to make different colours. So this tells us that we're going to need polyethylene, hydrogen peroxide, polyethylene, oh, luminol, as in lumen, as in lumos. Lumens. Is that why they talk about torches that have lumens? A torch has 1,000,000 lumens. That must be what that is. Polyethylene, polyethylene, polyethylene. Right, okay, and we can see in the order. So if we go in here, we can get this. So let me just clear my inventory again. And then let's do, there's our dye. And then we need to go into here. And we can just craft this now. So I'm going to make a green glow stick. Then I'm going to do polyethylene, polyethylene, luminol, and hydrogen peroxide. And that is going to give us a glow stick. And we'll do a red one as well. So we'll just put them in the order that we were told. Polyethylene, polyethylene, luminol, and hydrogen peroxide. And we're left with these glow sticks. So let's do time set crack. There we go. So we cracked it. Does it work though? Does it light the thing up? Not really. I mean, it looks glowy, but it's not glowy. That's okay though, I suppose. Can we stick it on a wall like a torch? No. Okay, but that's okay. Crack. And I suppose that's quite clever if I make another one and show you what that looks like. So let's just make another one quick. Let's just make another green one and show you what they both look like together. And throw one down on the ground and the other one down on the ground. You can see what they look like together, right? Whoops. So that's great. I mean, it has an effect. I'm just not sure what the practical application of that would be. And this can be done in any Minecraft world, by the way. So the way I'm thinking about this is when we go on to do We Are the Rangers, or we go on to do our Pompeii piece, for example, what is it I can learn and apply? And I'm going to show you a world at the end that we're working on just now for Minecraft, which is going to, it's basically, it needs this system, time set. It needs the chemistry system in order for us to be able to run it. The kids are going to have to science everything to survive in this world. You can change day to night with this switch. Okay, and we did that. Boom, boom. Okay. I like how that whirls around. I didn't know it did that. Look at that. That's neat. I'll look into how that was made. Lumos, root word. Sparklers. Use chloride to make different colours. So what do we need? We need mercuric chloride, magnesium, and a stick. So let's do that. Oh. And it's given us different things. Look, it said, look, you need a stick. This is to prove you're paying attention. You need magnesium, and then the thing we needed was mercuric chloride. Unless, I'm just going to take these all anyway. And actually I'm going to replace these. So stick, magnesium, the one we need, and then there. And then the 4 extras. It might be that they just use chlorides to make different colours. They just happen to have put mercuric up there. Okay, so we can make different ones. So let's try this. So let's do a stick, some magnesium. Now I remember when I was in science, I remember getting magnesium strips and you could light them and they shone really brightly. We probably didn't do what we were supposed to be doing with them. Oh, there's an orange one. So they give us, mercuric gives us red, calcium gives us orange, Is that consistent? Potassium gives us purple, and cerium gives us blue. And then what's that? Tungsten chloride gives us green. Look at that. Now what? What do we do with these? Oh, it's sparkling. Oh, let's switch the lights out and see if that makes a difference. I wonder how long they burn for. Oh, it tells you at the bottom. They've got a little green thing in there. Yes. Oh, I know what I'm going to do with this. I know exactly what I'm going to do with this. In our make and model series, I'm going to have the kids have yellow, or in this case orange, and green, and they can hold sparklers depending on which team, yellow or green, they think are doing best at the time. They can light up their sparklers. Just gives the kids something to do that are part of the in the weighting system that we have set up. Can you set fire to something with that? No. Oops. Oh, I got rid of it. No, I didn't. There it is. Let's try another one. Let's try an orange one. Oh, that looks fantastic. It doesn't light up, and that's a shame actually. I think that's a wasted opportunity because, for example, if I carry a torch in Minecraft, oh, that doesn't work either. I can put a torch there, but carrying it doesn't make a difference. What about glowstone? Because in Java, when you carry these things, it makes a difference in terms of when you're carrying it, it acts. But if I put that there, that would have been nice if I could have stuck the sparkler on the tree or put it on the ground. If those were droppable items or placeable items. I wonder if you could change that in the code. But anyway, that's really neat. How nice. All right, okay, so I'm quite happy with that. So let's try something else. Let's go. Now, hang on, before we try something else, here's the thing though. I'm already getting carried away at this point by thinking, oh look, we can make sparklers. But what I haven't appreciated is, let's just take mercuric chloride for example, that I want to then go back and understand how that's made. So we have to keep coming, in my opinion, we would have to keep coming back to these and saying, look, you know, the lab table gave us mercuric chloride, but how did we make it? Like, what is the element that allows us to get that? And I don't know, because right now I don't know what that's made of. And I think we can go in here and we can try that. So what does potassium chloride look like? Ah, look. So we go back to the material reducer and start again. So potassium chloride gives us chlorine, comes from 17 chlorine, and so just one chlorine and one potassium. So let's go back and work out how that worked. Let's test it over here actually. If we put in potassium and chlorine, it must be a set number because combine's not going to work. Look, we're going to get, what did we get there? We got rubbish. If you do it wrong, you get rubbish. So how do we know how many? Oh, it's burned. It's burned up. Let's do that again. Mercuric. Let's get mercuric. This time it's mercury. As mercuric. So we need to make mercury, which is 80, and chlorine, which is 17. Let's see if that works. Mercury and... No, see, that's not working. That's weird, because it's telling us what it's made of. It's just not letting us combine them. Oh, wait a minute, I'm in the wrong place. There, the compound creator. I put it in there, and I get it. I was in the wrong place. Awesome, so then I can make mercuric chloride. So this is the great thing about being able to go back and see how this looks. We're able to go back and say, look, mercury plus chlorine gives us mercuric chloride. And with mercuric chloride, we can create sparklers by merging them with magnesium. And notice magnesium is just the element. We just literally have the element and a stick. Okay, so always reverse engineering. Otherwise, I think you're making these cool inventions and you're not doing anything with them. You're like, hey, we made sparklers from mercuric chloride. But what is that? Balloons. Balloons are always nice. Sparkler on a balloon. Yeah, that would burn that balloon. Anyway, okay. Now what we got? Create a balloon by combining... These are lovely. Distracted. Let me just clear my inventory. Create a balloon by combining the pictured items at a crafting table. Okay, so we need latex, naturally. This is great because it's showing you how these things are made. You take these things for granted, right? You go to a birthday party, there's some balloons, but somebody, like, the latex is a chemical construct, which becomes a material thing. And then a lead, helium, we know we need to fill it with that gas, and then red in this case. So let's see. So what we got latex. Okay, let's do this. Let's get ourselves all of these things, except I want different dye. And the reason I want that is because I want to apply this to some different things. So I'm going to go in here and get yellow dye, and I also want to get green dye. I wonder if there's lime. It's lime I want. Glime. Oh, there is. There's lime dye. Yeah, that'll do. Right, okay, so let's try this. Let's do this. So we're going to go in here and say latex and latex. Helium. I'm just going to make as many of these as I can, actually. So let me just collect those again. I am going to have to do it that way. Doesn't matter. And then lime and a lead. Get lime balloons. Let's do that again, but with a different colour this time. Let's do orange. Purple. Just going to have to do that each time. Red. And then I'll show you what we do with them. Oh, red balloons are nice. Let's make 99 of them. You know what? I'm actually going to do that. We're going to make 99 red balloons, and I've done that wrong because I've distracted myself with some 80s pop. But we are going to do that. We're going to make 99 red balloons right here on this stream. Oh, not right now though. I want yellow first. I keep doing that wrong thing. Pay attention. Okay, that'll do. Yeah, it. Oh, we could do that as well. We could skin an NPC to look like it and then give it some balloons. And so what we can do now is we can go into the monster spawner and we can give it... Bye! Let's try it again. Now, what's interesting about this, and I just want to follow this up, is that that's moving way slower than the pig. Surely the pig is... What happens to them? This is an awful experiment. This is an awful, awful experiment. Can you imagine kids at home tying these to their hamsters? Because Minecraft said... Yeah, the pig's gone. The pig is gone. Did I miss the pig? Okay, we're heading back for the cow now. There's the cow, look. I'm so sorry, wee guy. I'm so sorry. Okay. Special retrieval, specimen retrieval device. Yeah, that's going to help. Oh, that's terrible. Right, okay, but fun. So that's a bow and arrow. So let's do this. Let's do it again. Stick a yellow balloon on there, and then Oh, I hit the peg, but not the balloon. Yeah, that's not going to work. So let's see. We've got a sheep and a cow, another cow, a mushroom, a pig. So let's try this. Let's go sheep, cow, pig, mushroom. Let's see which ones are... Oh, look. They're going quite slow. The pigs are gone already. And they're going this... Did we get the sheep? The sheep's gone. So we can look at the weight of an animal. I wonder if you can do it with other things. You can't do it with NPCs, I know that. But I wonder if you can do it with villagers. No, because you can only trade with a villager. Give me paper and I'll give you an emerald, because he's a librarian. All right. We're going to do a whole stream on... I know, right? Not the sheep. Yeah, we're the same in Scotland. Precious. So they are. See you, big guy. I wonder if I pop it. Can I pop it? No, I could do it with the bow though, surely. And the cow died. None of this is good for the cows. Anyway. I wonder what else you can do it with. It has to be entities, I imagine. So what about... I mean, I'm going to stick one to a rabbit anyway. I wonder if you stick one to a bird, like a parrot. So let's do... I'm trying to think what else you could stick it to that it would work. Oh, like, so if we did something really heavy, like a llama or a horse. Surely horses don't. What else? A rabbit, they're tiny. A parrot. A bat. Cats, ocelots, wolves, pigs, cows, chickens. I don't imagine you can stick one to fish. A panda? Let's try that afterward. Oh, a turtle. A sea turtle. Right, so let's try sea turtle, rabbit, bat. I need to be quick with the bat though. I don't think I can catch the bat. Well, the rabbit is gone. And that's going to go, sorry, wee guy. Oh. And the bat's away. Can't stick it to a turtle. Isn't that interesting that they've coded that so that only certain entities can have... Oh, there's the bat again. Oh, you're back for a tease, right? Okay, I'll get you. No, can't stick it to the bat. Okay. Oh, I've done that again. What else? What else? What else? Agent. You can't stick it to your agent. Ravagers, pillagers, drowned, squid, pufferfish. I can't imagine fish would... Strays, slimes, wither skeletons. That'll do. We just want to try a horse now. Oh, a big one. Let's get a big horse. Oh, oh, do the baby horses go faster? Ah, see, there's a flaw in the science. A baby horse doesn't go faster. It just registers it as a horse. Come on, Minecraft. Accuracy now, accuracy. And then finally, a parrot, which already has its... No, you're not allowed to stick it to anything that has wings. Okay, that's interesting. All right. So that's another experiment that we can do. What's this one? What's this one? Coloured torches. Ah, now I love this one. This one I love. And it's really simple. It's just cerium chloride. Now, I want to try something. I want to see if I go into inventory and look for cerium, I can get cerium, but I can't get cerium chloride. So as a creator of the game, if I want to make those torches, I have to make cerium chloride, which is quite interesting because you'd think that in creative mode, the lazy way to do it would be like, look, I know what I need. I'll just go in and get it, but you can't. You need, because even if I just, there's no way of getting that. So I can get cerium and I can go and make cerium chloride if I knew how. I also need torches. So what's cerium chloride, mercuric chloride, etc. So it's back to those chlorides that we had earlier. I wonder what makes yellow and green. This one, tungsten, makes green. Why is tungsten green? And then we're going to do just that and a torch. Gives us a green torch. Can we just stick these balloons to things? What have they got them stuck to? Ah, fence posts. Bye. Oh, that's nice. That's a nice animation. Okay. And then our green torches. So let's just make another torch. Let's just go into here and do potassium chloride with a torch. Purple. And then let's make mercuric. Mercuric's going to give us red, of course. And cerium's going to give us blue. And I'm sure we can make more. Tungsten. Okay. Tungsten is always green. Well, I've noticed tungsten is always green. I just don't know why. So now let's try this. Let's go back to our little clock here and switch it off. I love that animation. And let's do a green torch. A red. I mean, it doesn't do anything for the light. It just lights. But it just gives you a theme, I imagine. Blue's quite nice. What did we try? Purple. Yeah, purple, blue, green. So it just gives us different coloured torches. So that's nice. They're nice to haves. I don't know if they're it's like you know, freezing the water. You could maybe put that into a game deployment. Certainly the balloons you could gamify. First to make enough balloons to get rid of a field of cows, for example, and just gamify that. I you know, that was just off the top of my head. But they're nice to haves. I don't know if they're practical. Which is always my issue, you know, for those of you who know and have worked with me in the past. It's that one actually. For those of you who know me and have worked with me in the past, it's really important that these things are practical. I don't believe in technology for technology's sake, and I certainly don't believe in Minecraft for Minecraft's sake. So if we're trying to teach chemistry and all we get at the end of it is some nice coloured torches, and we haven't been able to explain the process by which those torches were made and how that process can be effective in other walks of life, I'm not entirely sure, other than exciting children about using Minecraft in the classroom to learn chemistry, I'm not sure what it is that we're doing. That's not to say that I love this. I do love this. But it must always come back to curriculum and pedagogy. And I don't know how you, for all teachers everywhere, we could make that such a thing. Make super fertilizer. Now I need this one. So let's see what that looks like. By combining exactly ammonia, NH3. So NH3, so we need 3 of those plus phosphorus. So there's ammonia, which I'm just going to take, and phosphorus, which I'm just going to take. Actually, wait a minute, Doctor. Is it not like 3 a.m. for you in New Zealand? 1, 2, 3, and then ammonia. Or was it just... Oh, look at that. It's just 1. Okay. I got lost with the number there. But anyway, boom, super fertilizer. Right. Now we can make super fertilizer doing... are there seeds in there? Yeah, there's seeds. So let's make a spruce sapling. Now you guys have seen me do this before anyway. So let's just go into our thing here and get a spruce sapling there. We've got our super fertilizer there. This is messy in the inventory, right? It's such a messy. I'm going to keep my balloon though, because I want to stick my balloon next to it. And that'll do. So let's place that there. Oh, you're stuck in Malaysia. Wow. Like stuck. Can't get home, stuck because of the virus. Boom! That's fantastic. And again, if we go into fertilizer and search for fertilizer, we can't get fertilizer. So we have to make fertilizer, which I think is fantastic, actually, in terms of helping the kids to, what does he say? Fascinating. That's all Louis says. So let's see what's in here now. This is the classroom. Creature containment hall. Give a kid a choice. This is one mistake in their design. Classroom. Creature containment hall. Classroom. Creature containment hall. I'm off. See ya. Right, where's the creature? There we are. Creature containment hall. What's going on in here? So this oh. Right, okay. They're really quite friendly. What are you up to in here? What is going on in here? What's it for? I don't know what the lesson is here. Is there a lesson? Oh, if it hits something, we didn't know that before. Pop. So you could do experiments with the weight of something based on the time it took for it to go up, pop, and come back down. That popping sound that you get. It didn't pop when it went up that way. So does it pop because it touches something in particular? Like that. Oops. Because it didn't. Yeah. So it pops when it touches wool, but it doesn't pop when it touches stone. So there's an experiment. I don't know why that. Okay, right. Okay, so it's not like you're at home and you're away from home and you're stuck and need to get back home. You're actually working there. Okay. Well, I'm sorry that you're stuck away from home. I love studying chemistry. Great. Okay. What's your favourite element? What else? What else have we got? I don't understand what was going on in there with the creature containment area. Testing area. Caution. I think this is just to make it look as if it's more of a lab. Let's stick to that. And in the classroom as well. I think what we need to do is turn this into a practical, like what's Dorothy saying at the front of the classroom? Has your school changed since the 1800s? Ours hasn't. Take your seats, please. I thought I could stick the balloon to something. Okay. And then there's our table of elements as well. And that's it, I think, for that. So let's head out of here now, save and exit, and see what I think one of the things you can do, and this is just, where are we? I'm just going to find some worlds there that we can use. Here's an idea. Hang on, I'm going to go back into the... I'm going to see if we can change torches. Can we change campfires? I doubt it. And I need to now go and remember what it was that I was supposed to do to get the torches. So it was just one of the chlorides with a torch. So what if we did a chloride? Oops, we can't do that. I need to keep the chlorides. It's what if we did a campfire or a glowstone or a lantern? I just want to see if it changes any of the other things. I doubt it very, very much. But if we put a campfire, hang on, how did we do it again? It was just a campfire in the middle, wasn't it? So put the campfire in the middle and then one of the chlorides. No. What about a glowstone in one of them? See, again, a little mistrick. That would have been awesome if you could put the campfire in and get the chloride or the glowstone, you could have changed them as well. But this is hard coded, so we'd have to change all sorts of code to be able to make that happen. That's a shame. All right. Yeah, Barry, you take it easy. I'm actually ending the stream now anyway. So that was the chemistry update. Lots to think about. I love it, but it has to be practical for me. I think once you've run it, you have to think about how these things are going to be practical. I was going to move into other worlds and kind of look at that practicality, but I think we'll do that on another stream. I think what we'll do is we'll do chemistry update. The next stream at 6 o'clock this evening will be chemistry update, where and why and how can it be used, rather than what does it do. And we'll do that on a separate stream. So listen, wherever you are in the world, you guys take care. Doctor, so good to have you in. I hope, it's a shame that you're stuck, but you're an amazing guy. Look after yourself. Stay indoors out there. There was upper end chemistry there too, was there? Well, I had no idea. Just playing around with it. But you guys all take care. Stay safe, stay indoors, stay healthy, stay sane. And I will see you at 6 o'clock BST. Take care. Bye.